All right, we are starting on page 433, and we're going to be working until 442. We'll be skipping some pages here and there. And this lesson, we're working on 3 activities plus a talk the talk. This is our last lesson in Module 3, Topic 1. So pretty soon we're going to be taking the Topic 1 test. But let's go and get started here. So these 3 lessons are all about comparing functions. So we're going to be comparing, well, at least for this first one, we'll be comparing rates of change. So we're going to be comparing various representations. So as you can see, function A is an equation, whereas function B is a graph. And it says analyze each pair of linear functions, identify which function has the greater rate of change. And when we talk about rate of change, we talk about slope. Okay, let's start with function A. This is in slope-intercept form, so it's easy to find the slope. The slope of this is m. So we would say that the rate of change, in this case, is 8. Let's see if function B has a larger rate of change. In this case, right, in order to find the slope of a line, you pick 2 points that we can use. I'll pick at the origin, and I'll pick right here at the coordinate 3, -3. And you're trying to find what's the rise and run. So it looks like we're going to have to go down if I start at this top point and then to the right. Going down, that means my rise is actually negative. It's -3. And going to the right, that's a +3. And the slope of this, it's a rise over run, so it's -3/3. And that means if we simplify it, it's -1. So which number has a greater rate of change? Function A has a slope of 8, and function B has a slope of -1. So we would say that function A is steeper. So I'll just put a check mark through it. So that's pretty much all we do, right? So we know how to find the slope of each one. But now let's move on to other representations. On the next page, page 434. So now we're comparing number 2, function C and D. We still have a graph, but now we have a table. Let's start with the graph since we're more familiar with it from the last problem. Pick some points that we can use. I'll pick this point and this point. I'll start at this bottom point. Let's go up and left. So my rise is +2, and my run, since I'm moving to the left, that means it's negative. You can count it's 1, 2, 3, 4, so -4. So the slope for the graph, m equal to, it's 2 over -4. We can simplify that. This does not equal 2, but if you were to divide each one by 2, all right, 2 divided by 2 is 1, 4 divided by 2 is 2, and we'll say it's a negative. Right, because negative divided by positive is still negative. All right, let's go back to C. So when we find the rate of change here, you're just trying to find how much it's changing by. So how much is our increase and decrease for each column? So let's start with the x. From -1 to 0, that's a +1. 0 to 2, that's a 2. And 2 to 5, that's a 3. And then on the y's, it's also increasing. This is increasing by, looks like it's 9. This is increasing 6. Oh, whoops, that's not 9. Increasing by 3. 6, and this is 9. Now, although we don't have a constant amount, they all equal the same thing, right? What's 3 divided by 1? That's 3. What's 6 divided by 2? It's 3. 9 divided by 3? It's 3. The rate of change for this, we'll put m equal to, it's just 3. Okay. So which one has the greater rate of change? That is, we'll say function C has the greater rate of change. Means that it has the biggest slope or bigger slope between the 2 functions. All right, and then now moving on to number 3. Let's now go to the table that we just left off on. Right, so this is a linear function. Let's start with our x's from -1 to 1. That's a +2 units away. This is also a 2. This is also a 2. And then now from here, -6 to +6, you're going to have to add 12. 6 plus 12 is 18, and 18 plus 12 is 30. So it actually doesn't matter which one we choose. We can choose the first one, right? It's always change of y over change in x, so 12 divided by 2. The rate of change for this one, for f, function f, is 6. Okay. And then let's go to, so this means it's a +6, so something very steep. With this is almost in slope-intercept form, right? Again, y equal to mx plus b, but it's not, right? We should have only the y on the left side. So I got to move this 6x to the other side. We're going to subtract 6x to both sides. So we're going to have y equal to, those 1 minus 6x are not like terms, so we just write both of them. That's a positive. This is now in slope-intercept form where -6 is our slope. So which one has the greater rate of change, meaning which one has the steepest? Like if this is +6, maybe -6 is something like this. Even though one is positive, one is negative, they both are 6. So we would say, since both are 6, negative or positive, we would say neither rate of change is greater. Rate of change is greater, right? They're equal. Okay, so just be mindful of that. So both lines have the same steepness, where function e has a slope of -6, function f has a slope of +6. You could think of this as -6, the absolute value of that, that's 6. And the absolute value of 6, that's 6. They're both 6 units away from 0. So meaning that they have the same steepness, although the direction is different. Okay, but the steepness is not. All right, we're going to skip a couple of pages here. So that's going to conclude activity 1 because we're not working on the next page for page 435, and we're also skipping 436, which is a continuation of the previous page. We're moving on to 437, which is activity 2 of really 4 total. All right. So like I said, right, this topic or this lesson is comparing functions. So now we're comparing it in context, so in problem situations. So we compared graphs, tables, equations, but we haven't done story problems yet. All right, so with this, let's go ahead and read the story problem. It says, Charlie's grandparents plan to purchase him a $100 gift card or gift certificate to an ebook club. There are 2 plans with comparable book offerings. The first one, Readers Are Us, charges each member $4.50 per month. Consider a relationship where y represents the amount of money remaining on the gift card, expressed as a function of the number of months in the club. Okay, so that's the first thing. So the first thing is $4.50. Okay, now we have to compare the second one, which is bookworms, represented by the table, and we know how to find the rate of change of a table, or we're just looking at the first difference. Okay, so let's go through here. 0 to 5, you just add 5. We should add 5 for all of these. And then for the other one, 100 to 75, you're subtracting 25, right? Subtracting 25 for each one. So the rate of change for this is -25 over 5. Negative divided by positive is a negative, and it can go into it 5 times. So what this is saying is the rate of change for bookworms is you're spending, right? We're losing $5 each month, or per book. So it's money out of this gift certificate. So that's why it's a negative. So we'll just say for bookworms, right, the rate of change is -5, but we're going to say the absolute value of -5 is just 5, right? It makes it everything positive. And then for the Readers Are Us, that was, right, $4.50. So we'll put -4.5. All right, so which one has the greater rate of change? Which one's the bigger number, pretty much? That is bookworms. So we'll just say this has the bigger or larger or greater I'm going to abbreviate R, lowercase o, capital C, as rate of change. Okay, all right, good. So B, which plan should Charlie's grandparents choose? We're pretty much just looking at which one is the cheaper option, right? Since Bookworms is going to cost more money, $5 per book. So we're going to say we want to use, they need to use Readers Are Us because it has a lower cost. All right. Now still continue with this, working with contexts, but now comparing it to a graph. Okay. So Washington County Recycle Center currently pays $20 per ton of loose cardboard. Jackson County Recycling represents their pay rate of cardboard using the graph shown. And then it says LaShonda needs to recycle her moving boxes and wants to earn the most money possible for her cardboard. So she's looking for more money, so we're going to look for a greater rate of change. Which recycling center should she choose because she's going to get more money? So let's find the rate of change here. I'll pick the origin, so this is proportional. And then what's a good point? Like, looks like this might be a good point here. Maybe this one. Let's see, where else is a good point? Let's just pick this one. We're gonna go up and then to the right. So up, we are going up 3 squares, but each unit is going by increments of 5. So this is 5, 10, 15. And going to the right, yes, we're moving 2 units, but every 2 units is a half. So this is actually just moving over 1. So this is 15 over 1. So the slope of this is 15, which tells us, right, this is the total value, $15 per 1 ton of cardboard. Okay. So LaShonda should take her moving boxes to Washington. Let's put Washington County. Put CTY Recycle Center. Okay. The reason is because she's going to be getting, she will receive, right, $20 per ton instead of 15. Okay. I mean, if you have a ton of cardboard, right, should we take it over here where I'm going to get $20 or to this other place, Jackson County Recycling, where I'm going to get $15? I'd rather get more money. So that's a little bit different than the previous situation because we're looking at spending less. This we're looking at receiving more. So that's why it's different there. So make sure that we're reading our contexts very carefully. Okay. Anyways, the next page is the last one that we're going to skip. But you're welcome to work through that. We're going to go to activity 3 on 439. Okay. So it says ordering rates of change. So we're going to put them in order from, for the most part, least to greatest. So it's exactly what we've been working on the previous problems, but we're going to have some positive slopes, some negative slopes, and so on. So just further additional practice. We're going to practice this together, and then you'll have the you-do on the next page. So before I can answer number 1, let's find the rates of change of each problem. Let's start with function A. I always like to start on the y-axis because I know that there's going to be a clear point on it. Let's pick, what's another good point to use? I think this one right here. Okay, I'll change this to red so it's a little bit easier to see. Looks like our axes are going by 1, so for this, we're going to go up and left. So we're going to go up 2, left 2, so that's left -2. So rise over run, this is 2 over -2, and that's equal to -1. Okay, so the slope of function A, it is -1, but we're trying to compare from least to greatest. So we don't want any negatives. So for this, we always put in absolute value. We're trying to find which one's the steepest. We don't care about direction, so whether it's positive or negative. Absolute value of -1 is +1. So let's just keep that in mind. We'll compare it later. All right, and then for function B, we're trying to, we have an equation. Whenever we have an equation, always convert it to slope-intercept form. So for this, I need to move y by itself. So let me get rid of this x. We'll have 4y equal to, I'll put negative x plus 12. I'll put negative 1x. And then we have this 4 in front that's multiplying. We're going to divide everything by 4. We have y equal to negative 1/4, and we'll put the x right next to it as a coefficient. And then 12 divided by 4, that is 3. So this in slope is in slope-intercept form. The slope is what's in front of x. It's a negative 1/4. So almost have it. Right, we don't care about the negative though, so we're just going to convert it to a positive. Absolute value of negative 1/4 is positive 1/4. So already with this, we can tell that, right, function A has a steeper rate of change than function B, right? 1 is greater than 1/4. Okay, and let's now move on to function C, the table. Right, I know that we can figure out each first difference, but I'm going to use just one of them. It actually doesn't matter which one you use if we know that it's linear. I'm going to choose the second to the third row. So from 0 to 2, that's plus 2. From 7 to 10, that's plus 3. So we know it's always y over x. So that means it's going to be 3 over 2. And that we can't simplify any further. We're going to just keep it like that. You could make it a mixed number, but that we'll just leave alone. I mean, you can't convert this to mixed number. This is 1 and 1/2. So we know that this is bigger than function A. Okay, so far this is in the lead. But let's go to function D, a context. The used bookstore will pay 50 cents for each book of, each box of hardcover books. So it's $50. So instead of putting it in terms of cents, I'm going to put this, since we have fractions, right, 0.5 as a fraction is just 1/2. All right, so let's go and go back to number 1, right? Put this in order from least to greatest, right? We have 1/2, 1/4, 1, and 3/2. So the smallest one is, oh, whoops, not that one, is 1/4. So we're going to put function B is the smallest. And then it goes function D, or 1/2. The next smallest is 1, which is function A. And then 3/2 is bigger, or 1 and 1/2 is bigger than 1. So function C is the largest rate of change in all 4 functions that we have here. Okay, all right, good. So using this understanding, we're going to make number 2 a you-do, where you're now comparing the varying rates of change and putting in order from least to greatest. And the context here looks like it's rides. All right, but we're going to move on to page 441. Okay. You know what? This we're going to forego. You're welcome to do this as a you-do, but it's essentially the same thing where you're finding the rates of change, but answering in different contexts. Let's move on to page 442, our last page of this topic. Okay. So we're gonna answer these varying problems. We crossed off number 4, but we're gonna do numbers 1, 2, and 3. For number 1, it says use what you know about linear functions and slope to answer each question. Number 1, create a situation to represent the table of values. So what's a context we can say? Okay, what story problem can we make up? So we know at -1, something is 5. At 0, let's say time, it's 10. 2, it's 20. 5 is 35. Okay, so what we can say is, if we think of x as time, or we're just creating, let's think about this in terms of money. So what can we say about this? Is this spending money? Is this saving money? We can say last month for -1 would be, that's what we're saying, last month. Whoops. Month. We can say that someone saved money, so we can say $5 in a savings account. I'll put ACCT. We'll say since 0, that means 0 is now. We'll say this month. It contains $10. And then for 2, that means in 2 months from now. So we say in 2 months, it will contain, or it will have $20. And we keep going for 5 months. In 5 months, we will have $35. So that's the situation there, right? Typically, X, many times we'll like to use time. So time in months or time in days. All right, number 2. Write an equation that will have a slope that is less steep than the relationship in the table. So the steepness of this table, or we can just keep going here. This is 5 over 1. This is 10 over 2. Now you could take 5 over 1 or 10 over 2. They all equal the same thing. They all equal 5. So we need to write an equation that is less steep, a number that's less than 5. Okay, we could write anything. We could put y equal to, what's a number that's less than 5? Let's say 4. 4x plus, it doesn't matter what we put here because that's, we'll put 10. Right, but what's really important here is that 4 is less than 5. And then number 3, how does the slope in this graph compare to the slope in questions 1 and 2? All right, so this is our last problem. Again, we're going to find some points. Let's pick this point and let's say this point right here. This is a rise of 4, a run of 4, and this is a slope of 1 because 4 divided by 4 is 1. Okay. So pretty much it is the slope of function of this third function is we'll say is smaller than both question 1 and 2, right? So it's smaller than 4 and 5. Okay. Anyways, so that's pretty much going to conclude comparing functions. So that did take right, a lot of our effort in understanding of various problems, right? Graphs, tables, and so on. But let's go to our assignment. Our assignment is on page 443. We're doing all in number 1 and all in number 2.